Welcome back to the Samir Critic. So previously we have discussed about the advanced application, advantage and disadvantage of the biomaterials based on their classification. So today we will discuss the factor on which success of biomaterials depends on after implantation. So first and uh, prime factor which is determine the success of the biomaterials or the factor on which the host response depends, so is the biocompatibility. So materials would be biocompatible in nature, so it will not any toxic reaction with the host tissue or host organs. So the definition is biocompatibility is the ability of the material to perform an appropriate host response as per Williams point of view in 1987. So basically, biocompatibility refers in a fact aspect concern of the absence of toxicity. So there is no toxicity or immunogenicity or carcinogenicity, and it should be blood compatible. So sometimes what's happen when the implant is placed into the body, so blood clotting will take place. So we have to think, we have to take care about that. So next is biocompatibility characteristics. So biocompatibility involves the acceptance of an artificial impact implant by the surrounding tissue and by the body as a whole. So this is the acceptance of an artificial implant by the surrounding tissue and body as a whole. Biocompatible materials do not interact the surrounding structure, do not provoke an abnormal inflammation response, do not incite allergic or immunologic reaction with the body, and as a whole do not cause any cancer formation. So basically the biocompatibility materials have a adequate mechanical properties. So mechanical properties should be good as well as optical properties and appropriate density. So this is the most key features of a biomaterials. So first and prime things that we have to keep in mind. Next, the other factor playing a role in the biocompatibility as the materialistics properties. So basically the chemistry of the material is very important, such as the bulk chemistry, surface chemistry, roughness, surface roughness of the implant, surface energy, surface charge, and so on. And next thing is the device what we manufacture or the implant what we create. So the elastic modulus or rigidity is very important, and next is size and safe. So another thing is which is important or play a important role in case of biocompatibility is the host response. So host response also depends on mostly on age and sex, and other things are tissue type and location. So I have discussed these things, that different body parts and different uh, body parts have different mechanical properties, physiochemical properties, structural morphology. So location wise we will decide which kind of biomaterials will we use. And also we have to take care of general health status before implantation. And the system, so system is very important. So implant tissue attachment, operative technique, and infection. So those are the prime factor or factor playing role in case of biocompatibility. So ISO 109931, how they define the biocompatibility? So a system of the material that is accordance with the following requirement is considered biocompatible. So this is tested according to the FD and CE norms. So this is the latest and important definition of biocompatibility, a system of material that is in acceptance with the following requirement. So what are the requirements? First is the safety, the condition of the animal welfare. So those are very important, okay? Because whenever we are going through any kind of manufacturing process, then after that it should be FDA approved or ISO certification we should require. So we have to keep those things in mind. And next is the testing genotoxicity and carcinogenicity, reproducible toxicity, blood interaction, what I mentioned previously, in vitro cytotoxicity test, local effect after implantation, EO sterilization residues, material degradation, irritation and sensitivity, sample preparation, systemic toxicity, identification and qualification of degradation product as well. So those are the things what we kept in mind to check our biocompatibility. Next, another properties of the biomaterials is biofunctionality. So simulating the function as good as possible, such as load bearing, articulating, keeping the blood running, filling the volume, creating electrical stimuli, and etc. So biofunctionality is also the very important. Mostly the load bearing application, mechanical, physical, and chemical properties is very important. But during articulating application, so we have to mostly check care of the corrosion resistance or the wear resistance. And whenever we case in case we have used in a there is a much more biofluid interaction, then that will be taken care also. Next is the mechano compatibility. So this is basically taken care for the load bearing application as well. The stresses on an implant should be perfectly in the same order as the stress exerted on the environment tissue to avoid the problem of stress shielding. So this is kept in mind. So before implant, which amount of stress has been generated, we have to study that, and then only we can go for our scaffold design, and that way we have to take our biomaterial as well. Next is the biostability. So biostability is the biomaterial will be either permanent, either temporary, or either biodegradable. So taking care in mind that if it is used for temporary purpose, so maybe we can go for bioinert one. If it is going for permanent prosthesis, then we have to check care that with time it will not degrade or it will not getting any toxic reaction with the biological system, or either it is biodegradable one. So we have to check those things before going through the implant process. And next is the reliability, reproducibility, and individuality adopted. So basically from the patient's own microcity data, if we going for the implant process, or if you start thinking of our implant process and the biomaterial which I will consider, then that will be perfect for implantation or the that will lead to the more successful implantation. So that is the mostly important factor on which the success of biomaterial depends. So that's all for today.